Hello everyone, this is part 2. It's slightly refined from my previous one, and I've moved it off my workbench of crap to try and let you see exactly what's going on. So the refinements I've made is I've changed this motor here. This motor is now a brushless motor, and it sort of runs between 6 and 24 volts. The advert said I'm running at around 12 volts. So to get me 12, because I'm powering the whole thing with 5 volts, I wanted the project to be a 5 volt supply. Even though this is running at 3 volts, is the microcontroller. I hate mixing voltages, but because you program this with 3 volts and they come with a regulator on. If I design a PCB for this, then I'll just run the whole thing with 5 volts. But to get the 12 volts on the motor, what I'm using is one of these boosts, and I've modified it. I tell you what, I'll just get a picture, so just give me a moment. I just want to show that. I'll just pause it. Right, yes. So this is what the boost I'm using. What I've done is I've desoldered this potentiometer here. I've left it connected on one side so that I can use this to set my my maximum voltage to the motor, because the motor will have a limit to how much voltage it can take, and I don't want to burn that out. And these boosts can get up to quite a high voltage. So basically I'm using the small blue potentiometer to set the max voltage that I can output to the motor. And then what I've added is this bigger potentiometer, which we can add a knob to actually adjust the RPM on the cylinder. And so we can do a manual adjustment and set the RPM. So basically what we've got is the blue one for the coarse main adjustment, and then we've got the added one, which I've had. Basically this is what I've done. What I've drawn here is just added another variable resistor between these two pins, so that we can do some fine adjustment of the RPM. Right, I'll just get back to the main video. Yeah, okay, so like I said, I've got a boost that boosts up the voltage to the brushless motor, and it's got a driver inbuilt inside the brushless motor. So basically it's got more torque, and it's by adding a max voltage I can just bypass the pulse width modulation, and it does the max speed relative to what voltage I put in, adjusting it with this big potentiometer here. So this is our main control. So we still have the amplifier to the speaker, and we have the little driver for driving this little motor that moves the trolley backwards and forwards. What I've done is I've added a switch. This is a 3-position switch. Center is off, and then one direction it turns power to most of it except for the trolley, and then the other way it adds power to everything including the trolley. So what we can do is we can actually turn it on now without the trolley, because when the trolley's in the park position, so basically when it's in the play position we hold it, pull it forward and put it onto the drum. But when we actually start, you know, put a cylinder on there and start it up, we want to check what the RPM is. So when I have this up in the park position, if this was activated, it would keep moving backwards and forwards depending which way it was resting. So what I have is a position on the switch where this is deactivated and it only rotates the drum. Okay, I thought it just best that I actually show what it is that we're actually playing. It is one of these Edison blue amber records, which come in like a cylinder form. So they're like a cylinder things, so it's quite an old thing. And to put it on my player, we just lift the mandrel up, which is tapered, so they only go on one way round. And basically we just squeeze it on slightly so it gets a nice grip. With it being tapered, you push it and it grips it. And what I'm going to do is, rather than use the amplifier, this little amplifier, and play it through this speaker, I'm going to connect it to my computer. So hopefully you'll be able to hear it. So let's just have a look and see what our RPM is like. Oh, why ain't that working now? Just one moment, please. Okay, yeah. I just hate these breadboards. Connections just don't stick together. So let's just get the RPM. Like I say, waggle off some more of these little wires, and let's just hope that that does it. There we go. Right, so we can see that we're doing 158, 159. Let's try and just get that perfect 60. A little more. There we are. And what we'll do is we'll just pull it forward into its play position, and I'll turn on the where's this wire come from? Oh dear. Yeah, where's that wire come from? I don't think it goes anywhere. Right. So I'll turn on the trolley. So the trolley now moves, and we'll just, I've got it too sensitive now. Right, let's just try and move that away a bit. There we go. Well, I hope you can hear that. So we're at 59. That's close enough. A little slow, but hopefully that should be playing. Now the sound quality will be not so good because I'm just using a normal LP stylus. The stylus for these should be one designed for the vertically cut, so these are actually vertically cut up and down. What I've got is an old one, and I got it set to 78, so it's like a 78, which is quite a big stylus, so hopefully it won't put in too much pressure in one point, if you get what I mean. You really need a proper stylus for these. I don't know where you get them, and they would probably be so expensive anyway. And getting a cartridge, well, these were made when we didn't have cartridges, so I don't know if you could actually get cartridges for vertically cut roots. Again, if you can, I guess they'll be pretty expensive. But as I say, this project was more of a proof of concept. It can be improved on. And so what I'm going to do actually is, I'm rambling over the music, I hope you can hear it. But what I'm going to do is I'm going to do a separate video of it just playing, and I'll shut up while it actually plays it as well. So anyway, this was just the part 2 video to show the improvements I've done. As you can see, it's quite stabilised. Really what this wants is a really fine potentiometer. I might drop it down to maybe 1K and try 1K to find one. I'm using a 4K potentiometer at the moment. I mean, any value will do, but actually it's I've been knocking these and I've really messed it up there. So yeah, I'll do another video of it just without me rambling over the top of it. Yeah, we could do with a better, more fine adjustable potentiometer, and then we can get it closer to the 160 that we want. I'm leaving it at that because it's really stable and it's not moving too much. So it looks like it's coming towards the end of the thing. It's obviously gone through the damage part, which I accidentally damaged. And I'm going to fix that, and I'll do a separate video with it just playing on its own. Okay, so I'll leave it, well, let's just finish that. Bring it back to the start. Put it there. Oops, got it. I'll just stop it there and then put it in its park position. And we're done with that. So I hope you enjoyed this video. It's been a bit of a pain doing it with that breadboard. Ever since I moved it from my bench, all the wires I just don't want to bloody stick. So anyway, thanks for watching, guys.